everyone. So today we are here to discuss the next topic of cloud computing, which is intercloud resource management, and we will be discussing about the various aspects of this topic. So we proceed regarding this particular different kind of services that we have in cloud computing. So we have a variety of services which are being provided by the cloud. So you can see here that we are having the cloud application like Concur, right now Telio, Kinexa. So these all are the applications which we are having in the cloud computing, in the cloud applications which are inside your software as a service model. Secondly, if we look at this cloud environment particular thing, cloud service environment, which is here as platform as a service. So we have Force.com, App Engine, Facebook, Microsoft Azure, NetSuite, IBM, Blue Cloud, and various kind of services. Next, we have the cloud software infrastructure, where we are actually building up the architecture of the cloud, and we have the computational resources, the storage, and the communications taking place over here, where the applications are the Amazon AWS and the open source IBM Ensemble and various applications like Banknorth. Other than that, we are having the colocation cloud services. So in the colocation cloud services, we have the Service, Internap, Entity Communication, the big names, providing us a variety of services as well. And the next is your network cloud services. So in the network cloud services, we have the OWest, AT&T, and the various services above net. And last, we have the hardware virtualization cloud services, which is the HAAS, where VMware, Intel, IBM, and Zen Enterprise are into the picture. Then next, we proceed to the resource provisioning and resource provisioning methods. So what are the various resource provisioning methods and the techniques that we have? So coming towards these applications and the services which the basic functions are providing, the clouds are based on the virtual resources which can be abstracted from the physical resources. Also, the virtual physical resources such as the virtual CPUs, the virtual storages, the networks, etc. we already have with us, and the virtual networks can be further divided into the vRouters, the vSwitches, the virtual firewalls, the VPNs, the interfaces, and the virtual links which are based on the physical router and the switch equipment and as per the requirements. So as in the diagram, we can see that we are having the various operating systems which are connected and having an interaction with each other, and then we are taking the virtualized operating system which we consider as the host operating systems, which are also called as the guest operating systems, which are being a part of this particular infrastructure in the architecture. Then the computational resources, they are managed in terms of your virtual machines or your virtual clusters. So the virtual clusters means we are having a group of operating systems where the instances providing the same services are the front-ended or a network load balancer, correct? Then next, what exactly resource provisioning means? So basically, when I discuss about the topic that what exactly a resource provisioning is, so it is basically to prepare your virtual machines with appropriate resources and making them ready for the user applications. So allocating the resources to the virtual machines is exactly what is required to match the workload. If we do not have efficient or the sufficient amount of the operating systems which we can exactly map up to the workloads, and so the efficiency would not be there and we would be lacking a lot of efficiency over there. So to prepare a virtual cluster here, you can see with appropriate instances is really very important, and it exactly makes it ready for the virtual cluster computation. Also, to manage the changes in the resources availability through your virtual machines restore or the migration are very important again. So to manage the things, the resources that we already have is again very important. In the goals, if we have a look here, so we have the high resource utilization, we have the energy efficiency, we have the reliability of services, and we have low performance interference. So these are certain very important things. So we must ensure that while we are managing or mapping the load efficiency and the resources to the efficient workload, so it has to be of high resource utilization. That is one of the goals. Secondly, energy efficiency. So there should be proper efficient utilization of the energy and the consumption should be efficient. Thirdly, we should have reliability of services. Whatever kind of services we are providing to them, they should be reliable. We should ensure that the services are reliable enough and they do not fail while we are working on a certain project or a certain application or a certain software to fulfill. Last but not least, we have low performance interference, means whenever there is a low performance and the resources are not able to allocate, so we interfere the efficiency of the the standard performance which we expect for the cloud to execute, right? So the cloud basically is nothing but, provisioning of the services. If we are not able to provide the services efficiently, then we are going to lack somewhere. So that is something which we have to keep in the mind. Next, now we have various scenarios in front of us. First of all, we are having, like, let's say we have 3 clients and they do have a resource broker 1, and then we are having RP1 and RP2, and they are like having the virtualized resources, the virtualized services, right? Then we have client 4 and client 5, they are having another cloud broker, the resource broker, they are having their own virtualized service. But one thing, if you notice over here, that all the services, they're like mapped and they're like into a mesh network. Every single resource broker is connected to another RP. Okay, so why we are taking this mesh network? Because the brokers are there to provide and customize the customers with the different kinds of services, and definitely it is possible that maybe this kind of virtualized service is not able to provide the services that this particular broker's customers want, so he will ask this one to provide and map with the services. So these kind of activities, they take place in different kind of scenarios. All right, so these are some of the scenarios which we might consider when we are looking at the customer requirements and we are efficiently fulfilling them. Now there are some of the entities, some of the major key players in the resource provisioning environment of the cloud. So number 1, it is the resource providers. And what exactly happens with the resource providers, that we do have the business companies, the cluster managers, and even the hosts which are providing the physical resources as the infrastructure as a service, right? So the business companies, or maybe the cluster managers or the host, they are actually there to provide you with the physical aspects of the resources. Secondly, the customers, the users or the end users, which are actually interested in the resource provisioning, who actually want that, we want the services, we want this kind of services to be customized with that kind of service. So they are actually the clients. And secondly, they do not have the knowledge regarding like how you're going to provide them the service, or what is going to be the efficiency, how they exactly have to use that, what is going to be the cost of that. So you have to provide the resources, you have to be very careful and ensure that the services or the resources that you're providing the clients is efficient and very good enough. Thirdly, we have the resource brokers. Now what happens with the resource brokers, that they are there to allocate for applications or the services on the virtual machines in order to fulfill the request of different clients, which we just saw in the previous diagram over here. So we are having the different kind of clients, and the resource brokers, they are there to fulfill the services of the clients which are actually demanding this is the kind of services we want, and that is not something that we don't want. So they manage the resources which are provided by several RPs, deploying the virtual machines on several physical servers and also in the same cloud. Thirdly, the resource allocation in order to obtain the particular most cost effective resources. So they have to also ensure that the resources or the services that they are going to provide to their customers is also cost efficient. Now we also do have a variety of the resource provisioning methods. Now what happens in the variety of resource provisioning methods, that there are 3 resource provisioning methods. Number 1, demand driven resource provisioning, where in the demand driven method, it provides the static resources and it has been used in the grid computing for like many years now. Secondly, the event driven resource provisioning. Now the event driven method is based on a predicted workload by time. Like if this kind of event happens, or let's say if this kind of event takes place in reality, then what exactly is going to be the workload distribution to my various operating systems or the guest operating systems, so that we ensure that the resource provisioning and the resource utilization is efficient and in the best way, right? Third, the popularity driven resource provisioning. Now what happens in popularity driven resource provisioning? The popularity driven method is based on internet traffic monitored. So like whenever we are monitoring the kind of internet traffic, like what is the kind of traffic which people are actually interested in, which are the websites which people are actually interested in, or what kind of services do people exactly want. Okay, like let's say we take example of the social media. So social media is like something very, very popular. Instagram is very popular, making reels is really very popular. So these days Google Drive is popularly being used. So you have to identify those applications or those softwares or the infrastructure which people are actually interested in. Then only it is possible to give them a high end and a very good the infrastructure in the architecture which they actually desire for or they look for. So these are some of the resource provisioning methods that we do have, where we discussed about the demand driven, event driven and popularity driven methods. Next, if we study about the demand driven resource provisioning method in detail, so the first one is that this method will always add or remove the computing instances which are based on the current utilization level of the allocated resources. So this method will either add or it will remove the computing instances when you are actually working on the utilization level at how better or how efficiently you are going to use those particular allocated resources. Number 2, whenever there is a resource which has surpassed a threshold for a certain amount of time, the scheme will either increase that resource based on the demand or it would decrease whenever there is a sudden deduction or the traffic is not actually interested in using the popular services, or maybe a different kind of software has appeared or some other platform is providing those services. So you have to be very careful about looking at the demand of the market or the demand of the clients that we do have. Number 3, whenever there is a resource and it is below a threshold for a certain amount of time, that resource could be decreased accordingly, correct? Then let's take an example of Amazon. Okay, Amazon implements an auto scale features in its EC2 platform. Okay, so it is implementing the auto scale feature, means whenever the number of users are increasing, so it is automatically increasing the kind of services which it has to provide. Then this method will also easy to implement, means this method, the upscaling and the downscaling of the customers or the services is really very easy to implement. So you actually also not waste a lot of time during this procedure, and also you implement and you work towards this thing, and you take care of everything, that whatever is happening is working in perspective or in accordance with the kind of demand the market is having. Lastly, the scheme will never work right if the workload is changing abruptly. So that means we should have an idea like what is the kind of trend that we are having or what kind of trend are we following. So the trend will always decide the kind of demand, and the softwares can only be allocated in that direction. So these are some things and some important points that we should keep in mind while we are working with the demand driven resource provisioning. Then secondly, event driven resource provisioning. So what will happen in this scheme is that the scheme will add or remove the machine instances which are based on a specific time event. So this scheme will always work better for the seasonal or predicted events, such as let's take an example of Christmas or the West and the Lunar New Year, or let's take some of the more popular festivals in India, like let's take example of Diwali. We have like Flipkart is having a sale on Diwali sale, or Myntra has an end of season sale. So they have certain schemes which work good for them. So similarly, in the cloud also, as being a cloud service provider, we have the responsibility to either add or remove the machine instances depending upon the specific time event. Like let's say it's like the summertime. Okay, the people do not want the clothes which they wear in winter, so there is no point of adding on that sale that you purchase clothes of winter or something like that. So we have to take care of the requirements of the clients that we are having. And also during these events, the number of users will grow before the event period, and they might also decrease during the event period. So it depends upon the kind of services that we are providing, the kind of management that we are keeping up while we are working with the clients. Also, the scheme always will anticipate the peak traffic before it happens, and this method results in the minimal loss of the quality of services. So if your event is predicted correctly, so if it is not predicted correctly, then you are going to have a loss of the resources and you are going to waste the provisioning of resources. So you have to utilize them well so that your resources could be utilized only when there is a demand or whenever there is an event created. Okay, so that is how we will be working. Next, there is a popularity driven resource provisioning. So that says in this particular method, your internet will search for popularity of certain applications and it creates instances by the popularity or the demand. So that means whatever thing is going popular or as per the trend on the internet, so this method will always search for that kind of application and create those kind of objects which are popular by the people or by the clients which are there in and using the services. Secondly, this particular scheme will also anticipate the increased traffic with popularity, and again this particular popularity driven resource provisioning again has a minimal loss quality of services and the predicted popularity is correct. Number 3, the resources may be wasted if the traffic does not occur as expected. So which says that the resources may be wasted if the traffic does not occur as expected, because we are basically working on the popularity. So if there is no popularity, or there is a wrong estimation of the popularity or a misunderstanding about the popularity of resource, then the resources that you are actually applying in giving to the people or distributing to them as a resource, they would usually be wasted. Like let's say they do not need those services which you're providing, you're charging those customers for those things, you're ultimately ending up losing those customers in the future, and they might end up getting customized services from some other cloud service provider. So these are some very, very important points. I'm again repeating it: demand driven resource provisioning, event driven resource provisioning, and popularity driven resource provisioning. Now there is another term which says global exchange of cloud resources. Now what do we exactly mean by global exchange of cloud resources? So in order to support a large number of applications, the service consumers from around the world and the cloud infrastructure providers, that is your infrastructure as a service, they have established the data centers, means where the data is actually allocated and stored and managed everywhere. So in multiple geographical locations, it's been distributed to a variety of places in the locations to provide you with the availability of the data. Redundancy means you're duplicating the data everywhere, and also you ensure that the data is always available. You ensure the reliability in case of the site failures. So your data center is having the responsibility to distribute the kind of situation whenever there is a site failure. So that particular site failure is successfully handled by the other things, and you can actually manage the allocation of resources to some other site. So let's say site A has failed. Okay, so you are successfully transferring the load of site A to site B. So that is what we are exactly doing in the global exchange of cloud resources. So globally we are having a lot of platforms which are providing these kind of services, and we manage through them. So like let's take again an example of Amazon, because it's actually a big name which has like developed a lot in cloud computing. So it is having data centers in the United States. Okay, so like it's just a location, one of the east coast and the other one is on the west coast, and one of it is in the Europe. So the currently Amazon expects its particular cloud customers, which is their software as a service providers, to express a preference regarding where they want this automatic mechanism for scaling its hosted services, right? Or let's say where they want their application services to be hosted. Okay, so now they are asking you, and they are like customizing it as per the preference of the users or the clients which are actually using it. That is why maybe Amazon is like getting more and more popular regarding or comparing it to the other cloud service providers. Or let's say the Amazon does not provide the seamless automatic mechanism. So it is not having any kind of automatic mechanism which will like provide the services or the hosted services across multiple geographically distributed data centers. But this particular approach that it is following, like customizing the services, it might also have a lot of disadvantages or a lot of shortcomings. Firstly, it could be difficult for those particular cloud customers to determine in advance for the best location for the hosting their services. As a customer, I might face a challenge in choosing my particular location, and also they may not know the origin of consumers of their services. Maybe I even do not know that. And secondly, the SaaS providers may not be able to meet the quality of service expectations of their service consumers originating from multiple geographical locations, right? So this is about global cloud computing platform, or the exchange of resources, of the cloud resources that we are discussing. So this again necessitates the building mechanism for seamless federation of your data centers of the cloud provider or providers which support the dynamic scaling of applications across your multiple domains in order to meet the quality of services targets of your cloud customers. Next, in addition to your single cloud infrastructure provider, we will be able to establish its data centers to possible locations throughout the world. And also the cloud application server, which is also your software as a service providers, it will have difficulty in meeting your quality of service expectations for all the consumers. Hence, they would like to make what? They would like to make use of the services of multiple cloud infrastructure service providers who can also provide you a better support for their specific consumer needs. Now, this is what we are discussing about the infrastructure provider, okay, infrastructure as a service. So, they will be able to establish the data centers across all the possible locations throughout the world, which would ultimately in return, the application service, means software as a service providers will have difficulty in meeting quality of service expectations. Why? Because now the cloud infrastructure will be like everywhere. So, this kind of requirement often arises in the enterprises with global operations and applications such as your internet services, media hosting and your web 2.0 applications. Again, this again necessitates the federation of your cloud infrastructure service providers for your seamless provisioning of the services across your different cloud providers. And to realize this, the Cloud Bus project at the University of Melbourne has also proposed the Intercloud Architecture supporting the brokering and exchange of your cloud resources for scaling applications and your multiple clouds. So, this is what we have to actually take care, like whatever thing is having with the federation of the cloud infrastructure, whatever standards they are creating within their organization, and they are actually trying to realize whatever requirements their customers have, whatever quality of service expectations their customers have to meet, or the cloud application services, security, usage and your multiple cloud infrastructure which is already on a global platform. How are they going to provide them and how are they going to support them basically for the specific consumer needs, which they usually say that we are going to customize the resources according to the customer requirements. So, how would it be possible, and ultimately at the end who is going to manage? So, we have to be very careful when we are working with the global exchange method. Then also, by realizing your intercloud architectural principles in the mechanism in their offering, the cloud service providers will be able to dynamically expand or resize their provisioning capability, which is based on your particular sudden spike in workload. Let's say your demand has suddenly spiked up by leasing the available computational and your storage capabilities from other cloud service providers. Also, they operate as a part of the market driven resource leasing federation, where your application service providers such as your Salesforce.com, which is again a very big name, host their services based on the negotiated service level agreement contracts. So, service level agreement contracts. Now, they again play a very important feature in this particular management of your cloud. So, whatever agreements you do have with your clients, with your brokers, let's say I am a cloud service provider, but there will always be a cloud service broker in between who will be managing my services, whatever services I am providing, and he will be mapping it to the customers. So, a cloud service provider, which is a CSP, is never responsible for mapping out a service to a customer. So, always we keep a cloud service broker in the middle so that he can map out and customize the services as whatever the customer wants. So, there are a plenty number of brokers who are available and just acting as a middleman and dividing the services from the cloud service provider to the cloud service user or the consumer. Also, there has been a driven let's say competitive market prices. There has been a competition in the deliver on demand, reliable, cost effective, quality of services or aware services which are based on virtualization technologies while ensuring your high quality standards. So, quality of services is a very important parameter while we are working on any kind of software platform and minimizing the service cost. So, definitely cloud has been popularized just because of its low cost, but we have to still ensure that the kind of services that the users are getting with that reduced or the minimal cost, so that is again effective. That should not be that the cost is reduced and the quality also got reduced. So, we have to reduce the cost but increase the quality. We have to reduce the cost but ensure the efficiency, reduce the cost but ensure the high profitability and the executability of the exchange and the global exchange of the resources. Also, they need to be able to utilize the market based utility models, which are based on the provisioning of virtualized software services and the federated hardware infrastructure among your users with the heterogeneous applications. Now, what does it mean? So, we need to be able to utilize the market based utilized models. So, that means the models which are already available there in the market, and we have to decide or define the basis for provisioning of the virtualized software services, or those with the federated hardware infrastructure which are among the heterogeneous application, means the applications which are interlinked or which are mixed but yet defined dependent on the other global resources. And in case there is a site failure, let's say there is a centralized site failure, so it should be able to manage whatever is the data center, the common data center, it should be able to manage any kind of site failure. So this is about your cloud architecture and the intercloud reference architecture. Now certain other things also do exist, like let's say they consist of client brokering and the coordinator services which are supporting the utility driven federation of the clouds, which is your application scheduling, the resource allocation and your migration of the workloads. So in this particular thing, the architecture cohesively couples the administratively and topologically distributed storage and the computing capability of the cloud. Now again, two important things, like let's say this is the cloud that we are having, okay. Now what should it have? It should have a distributed storage and a computing capability. So these two things are very, very important while we are working with the cloud. So we have to keep them cohesively coupled, okay. So they have to be cohesively coupled, and the administration has to be topologically distributed. Also, the system will always ease the cross domain capability integration for the on demand, flexible, energy efficient and reliable access to the infrastructure based on your virtualization technology. So what we exactly want here is that your whatever cloud you are consisting, or you are joining the features or the services, the client brokering, whosoever is the broker and he is managing your client, and your coordinator services which are supporting the utility federation of the clouds, or which actually include, like what kind of federation of clouds we are talking about. So we are talking about application scheduling, the resources allocation, the migration of the workload. So these kind of architecture, they have to be cohesively coupled and then monitored regularly topologically, and they should have again another algorithm where we can actually identify the computing capability of the cloud, or let's say the part of single resource leasing the abstraction. Then the cloud exchange. Now what does this basic term mean? So it is basically acting as a market maker for bringing together the service providers and the consumers. So it always aggregates the infrastructure demands from the application brokers and always evaluates them against the available supply currently published by the cloud coordinators. It also supports the trading of the cloud services which are based on the competitive economic commodity markets and your auctions. So I again repeat, it is acting as a market maker, means it is making the market and bringing the producers and consumers together. Also it is joining, means it is mixing the infrastructure demands from the application brokers, then actually identifying it, studying it and then matching it against the available supply currently published by the cloud coordinators. It supports the trading of cloud services based on your competitive economic models, such as your particular commodity market and the auctions which are regularly taking place. Then the cloud exchange is also participant to locate the providers and consumers with fitting offers. Like let's say I am a service provider, there is a customer who wants the services which I am exactly providing, so it will be also matching up those particular requirements. So such markets, they enable the infrastructure for trading based on the SLAs, and the SLA specifies the detail of the service to be provided. So if we talk about in terms of the metrics agreed upon by all the parties, in terms of quality, in terms of cost, in terms of time and everything, so there are a common agreement which has been based by all parties, incentives and penalties for meeting and violating the expectations respectively. Also, the availability of a banking system within the market will also ensure the financial transactions pertaining to the SLAs between participants, and they are carried out in a secure and dependable environment. So this is about your cloud exchange as a market. Now this is basically a kind of architecture for your intercloud architecture for exchange of resources through brokering. Okay, now you can see here in the diagram, this is broker 1, this is broker n, means in between there are n number of brokers which are involved and provisioning the kind of services from this particular enterprise, means these are the kind of resources that we do have. They do have a directory, bank and a auctioneer where the customers could actually go visit and find out which kind of service they are actually looking for. And there is also a computing cloud which is publishing offers over here and maintaining a directory out of it. So computing cloud and storage in cloud, so everything is there, and this is the kind of architecture we have for the customer could or the broker could request a kind of capacity. This is the kind of capacity or efficiency I'm looking for, and then this enterprise IT customer will be working on the kind of requirements and how they can fulfill it. They would actually register it into their bank and auction it accordingly. So this is the global cloud exchange, where all over the world, all over the globe, we are having a variety of services. So this is about your intercloud architecture for cloud exchange of resources through your brokering. I hope I'm clear in this. Thank you.